Fabric dyeing. Surfactants are used in the textile industry to help fabric dyeing. Due to their ability to form micelles, as shown previously, surfactants may host dye molecules in their inner micelle core. In this way, not only do they enhance the solubility of those dyes which are not soluble in neat water, but they also control the rate of fibre absorption in both water insoluble and water soluble dyes. This gives the dyed cloth an intense and uniform colour. This video shows a first experiment using 3 nylon fabric samples to be dyed in a water dyeing bath containing a blue dye which is water soluble. The dye in sample 2 is a solution containing the widely used commercial synthetic surfactant sodium dodecyl benazine sulfonate. The dye in sample 1 is a solution containing a biosurfactant derived from biomass residues as explained previously. A third sample is surfactant free in that it contains neither the synthetic surfactant nor the biosurfactant. 3 metal containers are prepared for the experiment. Into the first container goes the biosurfactant followed by the dye and water solution and finally the cloth sample to be dyed. The operation is then repeated for the other 2 containers, with the biosurfactant being replaced by the synthetic surfactant in the second container and with the absence of any type of surfactant in the third container. A second set of containers is prepared in the same way but using a red dye which is water insoluble. All the containers are closed and placed in a machine which shakes the dye baths for a fixed amount of time at a controlled temperature. At the end of the bath shaking cycle, the cloth samples are removed, rinsed with neat tap water and allowed to dry in air. The 6 dyed pieces of cloth, 3 blue and 3 red, are laid out next to each other. It is immediately obvious that regardless of dye colour, the samples dyed in solutions without either of the surfactants have come out with white stains on them, whereas the samples immersed in dyeing solutions containing the surfactants show a deep, uniform colour. The interesting thing, however, is that no difference appears between the samples dyed with the help of the biosurfactant and those dyed with the addition of the synthetic surfactant. This leads us to conclude that the biosurfactant performs as well as the synthetic surfactant. The implications are that biosurfactants derived from biomass residues could be efficiently used as chemical auxiliaries for the textile industry in place of synthetic surfactants.